Hello, this is Dr. Mode, and today in chemistry we are going to finish section 2 in chapter 15. Our scripture verse for today comes from Matthew chapter 25, verses 41 through 46. Then he also will say to those on the left hand, "Depart from me, you cursed, into the everlasting fire prepared for the devil and his angels. For I was hungry, and you gave me no food. I was thirsty, and you gave me no drink. I was a stranger, and you did not take me in. Naked, and you did not clothe me. Sick and in prison, and you did not visit me." Then they also will answer him, saying, "Lord, when did we see you hungry, or thirsty, or a stranger, or naked, or sick, or in prison, and did not minister to you?" Then he will answer them, saying, "Assuredly, I say to you, inasmuch as you did not do it to one of the least of these, you did not do it to me. And these will go away into everlasting punishment, but the righteous into everlasting life." So the essential question for today is, what do enthalpy and enthalpy change mean in terms of chemical reactions and physical processes? So thermochemistry is the study of heat changes that accompany these chemical reactions or phase changes. And every single chemical reaction and phase change either releases or absorbs heat. So I have an example reaction here at the bottom. So what we have is 4 moles of iron powder that is reacting with 3 moles of oxygen gas to form 2 moles of iron oxide. And you can see that there's an energy term that's also here in the equation. This says plus 1,625 kilojoules. What this is saying is that this reaction also, as a product, has this amount of heat that's produced. This is a large amount of heat, and this reaction is actually used in a couple of different areas. One is if you've ever used a hand warmer, hot hands, these little hand warmers use this reaction to warm up and stay warm. Also, food preparation, like for the military, MREs, will use this as well to heat up food. So enthalpy, symbolized by an H, a capital H, is the heat content of a system. And the heat of reaction is delta H. It's the change in enthalpy for a reaction. So we have an equation here, delta H of a reaction equals the H of the products minus the H of the reactants. So what's important for determining if a reaction is going to produce or absorb heat is the sign of delta H. So if delta H is negative, then heat is released to the surroundings. The reaction is exothermic and it's going to get hot, just like the reaction that we saw for the hot hands reaction there with iron and oxygen. So if delta H is positive, then heat is absorbed from the surroundings and the reaction is endothermic and gets cold. Okay? So also we were talking about Q in a previous lesson. Q, which is heat, equals that delta H of reaction at constant pressure.